everyone. I'm Tsai. I'm really happy to be here in Hydrocafe. And before I start to share my research, I would like to introduce myself a little bit. I'm currently working at the University of Tokio, and I did this research when I was working at working on my PhD research in Imperial College. We collaborated with the team in Bangladesh. We tried to find out um, what controls shallow groundwater salinity in the southwest coast of Bangladesh. So I already shared the research question. So to identify the what controls shallow groundwater salinity in a deltatic area, we plan to achieve this aim by using the Tsai investigation and the numerical modeling. But before I start to share how we did it, let me tell you some story about the coastal region of Bangladesh. Bangladesh is located at the Bengal Delta. This type of deltatic plain is often experiencing tidal flood and inundations. Its climate consists of monsoon season and dry season. Of course, this type of delta is very vulnerable to storm surge. Also, because the topography of the Bay of Bengal is quite shallow, and its funnel shape leads the storm surge to be stronger. We found that people in Bangladesh usually use the groundwater as a potable water, but in coastal region, groundwater is pervasive saline, as this figure shows that. Therefore, people seeking alternative, right here shows but the coastal groundwater well is really saline. So alternatively, they're using rainwater, which is fresh, and also pond water. They build the pond to harvest the rainwater for bathing and for daily basis. However, the water in the drinking pond is not fresh, and so there's still another way, like using river water. And for the groundwater in the deeper aquifer can be used, but in coastal area it's quite difficult to get the groundwater. So to protect the low-lying coastal area from flood and inundation, the government of Bangladesh has been developing over 125 polders. Polders means that it's a Dutch word that means embankment since 1960s. However, this embankment doesn't work very properly. Here is a serious example. This figure shows that after 2 years, the cyclone Ella left. Some areas are still underwater. So we try to find out what causes these drinking ponds and the shallow groundwater to be saline. Therefore, we choose the study area in the southwest coast of Bangladesh, and we monitor the drinking pond and its underlying sediment. as you can see, here is the pond water level, and two piezometers under its position, like for 1 meter and 3 meters. And we also monitor rainfall and evaporation, pond and groundwater level, abstraction, and solute concentration. And here is the lithological analysis. Here is the elevation map and the land use map, and the lithological analysis along A and A prong, and the lithological analysis at the smaller scale. And around 10 to 15 meter deep, the layer is the silty clay. And also here is the simulation parameter for the study area. So we use the above information and to develop the conceptual model. And here is the surface domain. We conceptualize the land use and the elevation data. And I have to introduce, we use the hydrosphere for running the numerical simulation. This program can couple the surface and subsurface domain, which is really beneficial for understanding the surface water and subsurface water. How do both they interactive? Before we start to do a model calibration, we just try to initialize the model. So the model was running for 100 years to get a proper groundwater salinity distribution. At the figure C, the field measurement, and it used the dot, the black dot means the field measurement. And we use the Aquagene interpolation and to get the proper salinity distribution. And now we put the evaporation, rainfall, abstraction data into the model to calibrate the model. We know this type of data is quite uncertainty, so we just try to fit the major data. So as we can see, the modeled data with the major data is are fit quite well. And during 2014 April, there was no any surge events or cyclone came to this area, but the pond salinity just kept rising up until onto the very high level. We don't know that the reason, but we guess that is because the next to the north side of the drinking pond, there is a stream farm. Maybe the saline water is just flow into the pond leaf. So that caused the pond salinity change huge. this is kind of similar to the storm surge events, and we use these kind of events to calibrate the model and see how how the groundwater salinity changed in the model, and also it shows the build-up salinity. So I think that's a really good example, and it didn't cause any life loss or any, property loss. So it's really good for the research, but yeah. So and try to get the surge level to see how the storm surge affect groundwater salinity. And here is the one representative case, as I show in the very beginning of the slides. And we did the two cases. The first one is no any remediation, and the second case is we try to clean up the pond at after storm surge left at day 7. So it just changed the tidal river level to surge level. So here is the result. If we didn't do any remediation, the groundwater and the pond salinity will goes up very high, and it decreased very slowly, and even after 5 years. But if we clean up the pond after storm surge left, it extremely decreased the pond and the groundwater salinity. So that means if we can, try to make an action after the storm surge left, it will be great to get the remedy for groundwater. So to sum up, this result demonstrates that the certain salt flux in the pond causes salinity to build up in underlying sediments, and the surge events associated with tropical cyclones that might be a main factor, and that causes the widespread surface and the groundwater salinity problem, which answer what control shallow groundwater salinity. And we also suggest if the embankment can work adequately to protect the polder from tidal and surge water inundation, and it might be decrease the groundwater salinity considerably. Yeah, so thank you very much for listening. Bye.